Okay, good morning, everyone. And I mean good morning. We are on to 7.5, our last section of the semester. We are nearing the end of the semester, and, it's going pretty well, provided you're doing your work on the Tuesdays and Thursdays that I have assigned. Other than that, let's get going with 7.5 by noting our title of our section where we're graphing quadratic functions. Okay, graphing quadratic functions is a little different than graphing linear functions. Where the linear functions are straight lines. These are going to be curved lines. So what we need for this in the operations is to, for example, have the what do we call that? The standard form of the quadratic equation, which is ax squared plus bx plus c, and we can get that equal to 0. All right, so given that, what is it we have to find? All right, so with this idea here is there are three things we're going to have to look for. And it is we have to find what is called the vertex. We have to find the x-intercepts and the y-intercepts, or intercept. Get rid of that. Just one intercept. X-intercepts are usually come in 2s, up to 2, I should say. All right, let's concentrate on, we know how to find the x-intercepts and the y-intercepts. To find the x-intercepts, we let y equal 0 and figure out what x will be. And when we're finding the y-intercepts, we let x equal 0 and find out what the y value is. Okay, so let's start with the vertex. The vertex, remember our ABCs in the quadratic equation, the vertex consists of finding negative b divided by 2a. Okay, this is an x value here that we're going to put in an ordered pair. So the x value is going to equal negative b divided by 2a. And then we have to find the y value by plugging in f of negative b over 2a. Okay, and that's going to give us the x value will be here, the y value will be here, and this is going to represent 1 point on the graph. So a couple more things about the vertex. If I have ax squared plus bx plus c, that equals 0, and I'm graphing this, then if the a is positive, that tells me my graph is going to open upwards. Okay, the vertex lies here at the bottom of the bowl. Okay, that's the 1 point that's represented by this, x, y, all this really. This is how I figure out what my values are, and I end up with x, comma, y, whatever those values happen to be, which is going to be represented by this point here. So this xy is going to be this point here. Okay, next, if I have negative ax squared plus bx plus c, that equals 0, then if this is a negative value of a, then my graph is going to open downward. And then my vertex becomes the highest point, which will be here. And this is your x, comma, y that we get from figuring out what the vertex is up here. And again, I'll point out this, all this here. All this right here. again, just like the first one, but it's opening downward. Okay. All right. So let's get a what shall I get? An example. Let's try it. Switch colors. And how about it? The first example then is going to be, oh, how about, I don't like that color. How about we switch it to blue? And I'm going to have this as my f of x is going to equal x squared minus 6x plus 5. Okay, and what about it? So let's see, what order do we want to do this in? Let's say we start with the vertex, the x-intercept, the y-intercept. All right, so the vertex comes from negative b. We're at negative b over 2a, comma, oh my God. Okay, my pen's giving me a hard time here. All right, so I got negative b over 2a, and then this is going to be f of negative b over 2a. All right, how do I get these values? Well, negative b, so this is a, b, c on our quadratic function. So I could say that a equals 1, b equals negative 6, and c equals 5. Okay, so I've got negative b, which is going to be, okay, I'm going to scratch this out here. And how about I erase them? And I'll get to those, I'll get that back later. So negative b is going to be negative 6 divided by 2a, and a happens to be 1. All right, so that's okay. This ends up equaling 6 divided by 2, which is 3. Now this f of negative b over 2a becomes f of 3. Okay, and I'm going to plug that 3 into this original equation. So it's going to look like, change colors. How about if I put it as 3 squared minus 6 times 3 plus 5. So it's going to be 9 minus 18 plus 5, which equals negative 4. So my ordered pair here is going to be 3, comma, negative 4. And this point here is the vertex. Okay, we'll leave it at that right now, because now I've got a couple other things to find, which is the x-intercept and the y-intercept. Okay, what I want to do next now is I maybe want to find the x-intercept, okay, or intercepts. Okay, I want to find the x-intercept and the y-intercept. All right, let's do the x-intercept first. So what do we know? Quadratic function, I got to get the equation equal to 0. So this is f of x, which is the same as y, that I'm going to make 0. All right, so it'll be 0 equals this x squared minus 6x plus 5. Okay, and it looks like I'm going to have to factor this x squared minus 6x plus 5. So I'm going to see if I can factor it in traditional sense here. So that means I'm going to set my lead coefficient as 1. So I'm going to set up my parentheses and fill it in. Minus, minus, and my two values would be 5 and 1. Okay, and what about it? My x-intercepts then are going to be when x equals 5 or when x equals 1. Okay, remember this is equal to 0. I'll bring it over on this side. I could have used the quadratic formula, I will use the quadratic formula if I can't factor it in the traditional way. Okay, so here is regardless, here is my my x-intercepts, 5 and 1. The last thing I want to find is the y-intercept, and that's probably the easiest of them all. All right, so now I want to say if I'm finding the y-intercept, I have to let x equal 0. So if x equals 0, remember I'm solving for y now. Y is not 0, I'm just finding out what the intercept is. So I'm going to leave the y there. And that means when x is 0, what would y be? So if x is 0, this would be 0 minus 0 plus 5 equals y. And you can see that y is going to equal, the y-intercept then is going to be 0, comma 5. Okay, let's scroll down. My x-intercepts are 5 and 1, or 1 and 5. These are intercepts, so I'm just not going to put them in the parentheses. I don't want you to get confused with a point on the graph, an ordered pair. The y-intercept we said was 5, 0, 5, 0, comma 5. Now we have all the components we need to graph this. So here's my thing. Okay, so here's my graph I'm going to use. The vertex is at 3, negative 4. So I go over 1, 2, 3, and down 4. Just a little dot there. My x-intercepts are 5 and 1, or 1 and 5. So the 1 is here, 5 is here. And you'll notice, there's a little time to check, this point here, this line here, is called the line of symmetry. Okay, that's going to go right down the middle of the bowl. And when I come to the x-axis here and meet that, I can see that it is 2 units away from the 5 and 2 units away from the 1 on either side. So that kind of tells me I'm doing it right. I've got my x-intercepts, I've got my vertex here, and now I just have to find the y, or I found it already, but I have to plot the y-intercept, which is 5, 0, 5, and that's way up here. Okay, this is symmetric too, this line of symmetry with respect to the y-axis. So here I'm 1, 2, 3 units to the left. That means 3 units to the right would be the other end of the parabola. Okay, and you can see the shape forming, and this is my sketch of the quadratic function that we are talking about. And they're sketches, basically, is all it is. That's all I'm looking for. Okay, and that is example 1. There is another way of finding the vertex and the x-intercept and y-intercept. That is done by completing the square. You may like this better. Not sure, but let's try it. At least you have a little experience with it. All right, so if I am going to find the vertex by completing the square, well, let's say I'll use that same problem where it was x squared. What did I say? F of x equals x squared, and that was minus 6x plus 5. That equals 0. Get my quadratic equal to 0, and I'm going to complete the square now. Okay, so what have I got? I'm going to start off by subtracting 5 from both sides. And I've got x squared minus 6x plus something that equals negative 5. Okay, let's fill in this blank here, and we do that by taking the middle term, negative 6, divided by 2, and then I'm going to square it. So this is going to end up equaling 9. 9, so I'm going to add 9 to both sides. Okay, I'm going to factor this now in the binomial squared form. So this is going to end up equaling x minus 3 squared. And that's going to equal 4. Negative 5 plus 9 is 4. Okay, I want to get this back equal to 0. So I'm going to write this up as x minus 3 squared minus 4. That equals 0. And now I can find the vertex by taking the 3 and the negative 4. I'm looking at this as positive 3 because I want to know what makes this 0 in the parentheses. So that would x would have to equal 3. Okay, so that's my first component of the ordered pair, 3, and the negative 4 is negative 4. And this is the same vertex we had with the standard form method of doing it, the quadratic. Okay, 3, negative 4. So I completed the squared, and leaving it in the binomial squared form, I get 3, negative 4. So this number is the opposite of negative 3, which is positive 3, and negative 4 is what it is, which is negative 4. So just be aware here of what we have to do. I look at it as what makes this 0 in the parentheses when x is positive 3, which is the opposite of negative 3. Okay, and then the other way to go about that is to say you can find your x-intercepts the same way by letting y equal 0. Okay, that's how it works though. Let's go to example 2 now. Let's see what we've got. And it's an option, it's a choice there to take the what method you use. As far as the methodology, you can use the standard form. The equation's given to you in standard form, make it standard form. You could put it into the, I call it the HK form. You haven't learned that yet, but you will in college algebra. That's part of the formula that we use here, but I won't bore you with that now. All right, let's go on to example 2. Okay, here's our example. It's negative x squared minus 2x plus 3 equals 0. And the first thing we want to find out is what is the vertex. Okay, and remember the vertex is negative b over 2a and f of negative b over 2a. As such, remember this is all in a parentheses. This is going to be x comma y, and let's fill it in. So I've got negative b, which is negative 2, negative negative 2. Okay, I'm finding the vertex given the original equation. So I got negative negative 2, that's negative b over 2 times a, and this time a is negative 1. So with that negative in the front, that tells me this vertex is going to be a maximum. It's going to be at the top of the parabola. All right, so this, when I do the arithmetic on that, that's going to be 2 over negative 2, which equals negative 1. Okay, so this is negative b over 2a, which is negative 1. Now, where I have that f of negative b over 2a, that's going to turn into, you got it, 1, f of 1. And I'm going to plug in 1 into this original equation. Okay? So I'm going to have negative 1, negative negative 1 squared. Yeah, originally I had positive 2 divided by negative 2, which is negative 1. So that means f of negative 1. And negative 1 squared minus 2 times negative 1 plus 3 equals 0. Okay, so all this, I don't even need the equal 0. I want to figure out what this equals in itself. So I got -1 plus 2 plus 3. So look like 5 minus 1 is 4. Okay, so my vertex then becomes -1 comma 4. Vertex. Okay. Next, I want to find, vertex was -1 comma 4. I'll write it down here, I guess. All right, next I want to find the x-intercepts. And that's a matter of factoring this, this problem here, this quadratic. So if I'm factoring it, I want to factor out that negative at the beginning of the equation here. I don't like working with negative x squared in that first term, so I can factor that out, or I can divide everything by -1. So I only factor, that's what I usually do. Factor out a -1, put back what's left over. Then I'm going to have x squared plus 2x minus 3. Okay, I'm factoring this, so I don't need the equal to 0. I'm looking for the x-intercepts. Okay, so here's what I've got. I can discount the -1 now and work with the positive x squared plus 2x minus 3. Okay, and I want to factor that. And if I do, I get x and x plus and minus, and it looks like I'd have a 3 and a 1. Okay, so it's going to be, it is equal to 0. My mistake. Equal to 0. So to make this true, x is going to equal -3, or x is going to equal 1. And those are my x-intercepts, -3, comma 1. Okay, these are braces that I use instead of the parentheses, just to indicate these are the solutions for the x-intercepts. Okay, my last thing I have to find, which is the easiest, is the y-intercept. The y-intercept, and that is when x is 0. That's the easiest one. So when x is 0 in the original equation here, then I'm going to have 0 minus 0 plus 3, and that's going to be that's going to equal y now, not 0. So I've got y equals 3. So that's my y-intercept of 3. I'm just letting x equal 0. Okay, there's all the information I need to graph this function. So let's go. So I got my vertex is -1, 4. -1 up here is 4. Oh, that's negative. That's right. So that helps me know I'm doing it right. -1, 4. So this is the top of the parabola. My x-intercepts are -3 and 1. Well, here's -3, and here's 1 over here. So if I draw my line of symmetry going down, I can see they are equidistant from x equals -1, which is the line of symmetry. So far, so good. I just have now to plot the y-intercept, which is 3, or commonly known as 0, 3. And 0, 3 is here. Is that nice? And then the other side of that would be, well, this is 1 unit away from the line of symmetry, this at the y-axis, so it's going to be 1 to the left for my line of symmetry. And there's the sketch. I can see it. And there it is. I got the shakes today. But there we go. Okay, and that's the graph of example 2. All right, how about example 3? A little bit more challenging. Again, I want to start with the vertex. You can start with x-intercepts, y-intercepts, then the vertex. It doesn't matter the order. I'm just starting with the vertex. because I want you to get used to saying what is negative b over 2a, comma, f of negative b over 2a. There. That's my guide, if you will. All right, so negative b over 2a. So this is it. And I'm going to get this out of the, no, I'm not. So I'll leave it. So negative b over 2a. This is negative 6 divided by 2, and a is 3 this time. So this is going to give me 6 over 6, which equals 1. All right, so for f of negative b over 2a, it's going to be f of 1. Now I got to find the y value. So I'm going to plug in 1 for the x's and figure out what that equals. All right, so how about, well, let me change something. And what I'm changing is 3 times 1 squared minus 6 times 1 plus 1. What does that equal? This is going to be 3 minus 6 plus 1, which will equal negative 2. So my ordered pair for my vertex is going to be 1, comma, negative 2. That's the vertex. I'll write it again over here and over here. 1, comma, negative 2. Okay. Next, we'll find the x-intercepts. Now to find the x-intercepts, we have to let y equal 0. Okay, so that means it's just going to be 0 there. And how about instead of that way, how about I just change this to be 0. Okay, now I have to factor this. If I factor this, I can't use the traditional way because it won't work. So I'm going to use the quadratic formula. All right, the quadratic formula, negative b plus or minus the square root b squared minus 4 times a times c, all divided by 2 times a. Okay, so let's fill it in. I'll do that over here. So it's going to be negative 6 plus or minus the square root of b squared, so that's 36, minus 4 times a, which is 3, times 4 times a times c, which is 1. Extend my line there, parentheses. Okay, and that's going to all be over 2 times a, which is 2 times 3. Okay, let's figure it out more. So I got positive 6 plus or minus, let's see, I've got 36 minus 12. 36 minus 12. What is that? 4. 3 minus 1 is 2. And that's going to be the square root of 24. 36 minus 12. Okay. And how about all that being over 6? 2 times 3 is 6. So I got some simplifying to do here. I'll take that 24. Whoops. Let's take the 24. And what can we say about that? That would be 4 times 6 is 24. If I take the square root of that, square root of 4 is 2, comes out, and the 6 remains inside. So it looks like I'm going to have 6 plus or minus 2 root 6, all divided by 6. And finally, I can write this up as, what shall I do with that? How about I simplify it? Now, what I like to do is factor out the greatest common factor from the 6 and the 2. because these are factors. So in this case here in the top, this here I can take a 2 out. If I take a 2 out, then what's left? And that would be 3. If I take a 2 out, 6 divided by 2 is 3, plus or minus square root of 6. And that will all be divided by 6. And then that allows me, this is where I'm at right now, that allows me to simplify the 2 and the 6 since they're factors. 2 goes into 2 once, 2 goes into 6 3 times. So I've got two numbers for the x-intercepts, which is going to be 3 plus or minus the square root of 6. Okay? Okay, now using the x-intercept is 3 plus the square root of 6 and 3 minus the square root of 6, we can get like a decimal approximations for when we're graphing these on the graph. So looking at 3 plus the square root of 6, well, it's a little bit more, it's more than 3, but less than 4. But let's see, if I plug this in, what do I get? Let me see if I can do this real quick. And that would be 3 plus the square root of 6, and it's telling me it's 5.44. So one of my numbers is 5.44. We could kind of do that rounding and make it 5.5. All right, then if I have 3 minus the square root of 6, then that's going to give me an amount of, it looks like 0.55. So we got 0.55. So that's about 1/2. And these are my, I want the squiggly brackets, because these are solutions to that x-intercepts. Okay, those are my x-intercepts. Lastly, I need the y-intercept. So that's a good one. So when x is 0, y is just going to be 1. 0 minus 0 plus 1, and we'll say this is y now. So y is going to equal 1. That's the y-intercept. Okay, so we've got that here. Here's all my information now. Let's see what I do with my graph. Okay, here's the graph. Plot the points. Vertex first, 1, -2. That's here. And then I said my x-intercepts is 5.4, which is 5.5. Let's say it's here. And 3 minus root 6 is 1/2. Oh, something's wrong here. What is wrong? Okay, what's wrong is I'm needed to divide this by 3 as well. Do this. Okay, that'll make a difference. So I could take the 5.44, and this is just calculator work here, 5.44 and divide it by 3. And that gives me a 1.8. So this, instead of 5.44, will be 1.8, close enough to 2. And then the 0.55 divided by 3 will give me 0.18. And that's going to be 0.18, which is almost 0. All right, so I'm going to use these two numbers instead. All right, change this a little bit. And how about, let me fine tune that. Here, let me put a smaller ink on it. All right, so my x-intercepts now are going to be 1.8, which is just short of 2. There's 1.8, I'm going to say. This is 0.18, is like 2/10. I'll say it's here, real close to the 0. All right, and now my vertex, I could say, was what? 1, -2. Oh, that looks a lot better. So I'm going to go over 1, down 2. So there's my vertex. here. And basically I had a y-intercept of 1, which is here. And on the other side, it'll be 1 unit to the right of x equals 1. And that'll be here. So this little guy here is my graph. And we'll leave it at that. Okay. All right. So, sorry about that little mistake there, but we got to divide it by 3. And that's why I factor that 2 out. And it was originally 2 over 6 that made it 1 over 3. Okay, that was example 3. And if that's example 3, let's go on to example 4. Okay, here's example 4. Got my ABCs there and etc. Let's figure out what the vertex is. Vertex is first. So I'm going to have negative b over 2a, so that's negative 6 over 2 times a, and a is negative 2. So that gives me negative 6 over negative 4, which simplifies to be 3 over 2. And what about that? 3 over 2 is my x value. And now I got to plug in 3 over 2 into the equation to get the y value. So I know that this is 3 over 2, comma, for my vertex. And let's figure out what y is going to be. So plugging this in. So I'll rewrite it. All right, so here we have it. I just plugged in 3/2 into the original equation. Negative 2 times 3/2 squared plus 6 times 3/2 minus 5. And let's determine what that equals. So f of x is y, of course. So first I'm going to have negative 2 times 9 over 4. How's that? And plus, we'll call that 18 over 2 minus 5. You can let your calculator do all this too, by the way. Here I'm going to have negative 18 over 4, which simplifies to be negative 9 over 2 plus, what's that going to be? 9 minus 5. Okay, 9 minus 5 is 4. And then 4 minus, what is that? 4.5. 9 divided by 2 is 4.5. So I got 4 minus 4.5, which is going to equal negative 0.5. And what is this for? This is all for my y value. Make sure I did that right. Okay, that looks good. And this is what y is going to be. So my vertex here is going to end up 3/2, and this is going to be negative 1/2. Negative 1 over 2. And that's my vertex at this point. Okay, let's figure out what the x-intercepts are. So the x-intercepts will be the quadratic function equal to 0, and I have to factor this function. Y is 0. So if I factor this, it looks like I'm best using the quadratic formula. Doesn't look like I can factor that in the traditional sense. So let's do that. So I'm going to have negative b, so it's going to be negative 6 plus or minus the square root of b squared, 36, minus 4 times a, which is negative 2, and times c, which is negative 5. Okay, looks like I'm going to have a negative radical sign here. And that's okay. We'll have ways of doing that, of figuring that out. And what's it going to be? And all over 2 times a, and a was -2. There, can't forget that. All right, so what have I got? I've got -6 plus or minus, we've got 36 minus, let's see, how about that? 4 times 2 is 8. 8 times 5 is 40. So that's going to be -40. Okay, and that'll get me -6 plus or minus the square root of -4. Ah, -4. And here I'm going to get imaginary numbers as part of my x-intercepts. All right, so I'm going to rewrite this to be -6 plus or minus 2i. And that's all going to be over -4. And if I simplify that, looks like I don't really have to, because I'm going to plug this in, I think, to the calculator, but just we'll practice simplifying. So here I can take out a maybe a -2. If I took out a -2, then what would be left is I'd have 3 plus or minus I. And that would all be over -4. Canceling this out, the 2 over the 4, that's 1/2. So cancel this, and a 2 goes below. Okay, so I come up with a x-intercepts of being 3 plus or minus I. 3 plus I or 3 minus I. But now that we have imaginary numbers in part of our solutions for the x-intercepts, that's telling me that the line of the graph of the parabola in particular is not going to cross the x-axis. Okay, so let's see. What am I got here? The original equation is -2x squared, the lead term. So that means it's going to open up downward. We call that concave down. And it's going to be below the x-axis. So let's see. I've got one more thing to figure out. We did the x-intercepts, but what's the y-intercept going to be? And it looks like when x equals 0, that y is going to be -5. And that would be my y-intercept. So y-intercept equals 0, -5. All right, that's important. And let's see what we can do with that. So all this for the x-intercept is for naught. Okay, let's bring a graph back. Let's bring the graph back and see what we've got. So we said originally that the vertex is 3/2, -1/2. Okay, so if that's the case here, I want to get that smaller tip on my pen. So I got 3/2 and -1/2. So 3/2 is 1.5. There's 1.5. And then I'm going to go down, let's see, -1/2. 3/2, -1/2. So I'm going to go down 1/2, which will be right here. So this is my vertex. And it's going to open up going down. So I don't have x-intercepts. But I do have a y-intercept, and that y-intercept was -5. Let me make sure. Y-intercept is 0, -5, and that's where this is. So this is my line of symmetry at 1.5. And what does that mean? I'm 1.5 to the left, and then I have to go 1.5 to the right to complete that parabola. And this is enough of a sketch to get me where I need to go. And that's my graph. I couldn't use the x-intercepts because there weren't any. but I can use this. And that works out quite well for my graph. So remember, when you are determining your x-intercepts using the quadratic formula or completing the square, whichever method you choose, that you're going to have a negative square root somewhere, which we determined was at this point here. Let me outline this in red. This tells me I have imaginary numbers for the x-intercept. So you can basically stop there. You don't have to do all this because you have an imaginary number. That means you're not going to have any x-intercepts. So you can stop it right here. And then go on and find your y-intercept. And of course your vertex is super important too. All right, let's do some application problems now. Let's try that. Okay, here we go. Story problems, application problems. Do not be alarmed. We're going to do the same methods, the same procedures, given that they give us the equation, the quadratic equation. They're giving us the most important part. So now I've got an A, a B, and a C, right? A, B, C. And we have the tools now to help us solve that. Using your calculator, because we've got decimal numbers, is real helpful. All right, it says a company selling copies of an accounting program for home computers finds that it will make a weekly profit of P dollars from selling X copies of the program. According to the function, P of X equals that. You can read that. How many copies of the program should it sell to make the largest possible profit? And what is the largest possible profit? So this is interesting. It gets interesting now because here I've got a negative lead coefficient. All right, so that tells me on my graph that if it's opening downward, then I'm going to have a maximum here. And that tells us so much. So my value here for this, the X values here are the number of copies sold, and the Y value is the dollar amount. And so this is the largest Y value. This is the largest amount of dollars that you can make. And how many copies do you have to sell according to this equation? All right, so I've got in X is the dollars, the amount of dollars that we're going to make from selling X copies. And then the grand total is going to be the Y value. All right, so let's see. In order to do that, first find the vertex. How many copies of the program should it sell to make the largest possible